So what we do is in the user interface, we will set that to 100%. When you give this a contact closure, the unit interprets that as it locks out 100% of the cooling. Doesn't allow it to run. So that's kind of your cooling enable, kind of like a cooling enable disable. It's meant for utility. If you got a load on the grid, and we do a lot of demand response as a company, we are in contact and partnership with the utilities. They have a grid event. They ask us to shed load.
Okay.
So we usually will raise our set point 1 degree. All right, or 2 degrees.
And that's automatic.
And that's automatic in the system. And then, of course, that'll unload your machines or shut machines off.
No shit.
That's what this demand limit was intended for. And you can program it as 0%, meaning you can lock out 0% of the cooling. You can lock out 50% of the cooling, or you can lock out 100% of the cooling. We don't use this for that utility demand limit strategy, but we use it as a mechanical cooling lockout. So we set it up for 100%. When we give this a closure, the unit can't run cooling.
But when do you do that? If you're not using it for the utility?
Let's say that our set point is 74, and we've been running cooling with this unit, and our temperature in the space is now down, and I could tell you the exact parameters, but I'm just giving you a general term. We've been running cooling. The VFD has been humping, running fast. We're cooling the space down. The VFD gets slowing down. Our supply temp, which I'll talk about, is going up. The temperature in the store gets down to, let's say, 72 degrees in this space. We say we no longer need mechanical cooling.
Okay.
Click. Now the fan will keep running, but we turn the cooling off.
Gotcha.
That's what we use that for.
And just to reiterate, you're saying you do not use that from the utility company to shut this off?
We don't. That's what it's.
You could.
That's what it's kind of intended for. We kind of hijack it, and we use it as a cooling lockout. That's what we call it, mechanical cool lockout.
Maybe that's what Billy had. Somebody put that in his head about not. I don't know. I'll have to ask Billy where he got that shit at.
Mechanical cool. That's in the software. The points. If you had a point list, we call it mechanical cool lockout. On the unit, it's called demand limit.
Okay.
And that is under setup, under general. Right there. Demand limit definition.
Okay.
Cooling is 100%. We're set up for 100% lockout.
Okay.
The options are 0, 50, or 100.
Okay.
You can't say give me 25% of your cooler.
Yeah.
It's 0, 50, or 100.
Okay.
So we set that to 100. When you get a contact closure on TB5 1 to 2, it.
So if this is at a 50%,
you lock out.
So that could be why we're sometimes not wondering what the hell's wrong, why we're not running all the compressors.
If it's set for 50, and if someone set it for 50 and that contact is closed.
But you're saying this is 100.
This one's 100.
Okay. So we probably need to investigate that. So
yeah, that's under the setup.
I would hope that they just leave it at 100 because that's just too many more.
Right there, you can go. There's your 50 and none, 50 and 100. There's your 3 options.
Okay. All right, that makes sense.
So that is kind of a cooling. Think of it as cooling enable disable, right?
Sure.
The space is cool downstairs. We're below set point. We got so low below set point for whatever reason, and the system says we don't need cooling. Lock it out. Turn it off. Okay? In conjunction with the cooling enable disable is that supply air set point that you were referring to. That supply air set point, so This is where the G-Bass 0 to 10. Next, G-Bass. Trane has two. So these units are from the factory. They're a 40 to 90 degree range for cooling. Okay. 40 to 90. Mm-hmm. They offer two types of G-Bass options: a 0 to 5 volt and a 0 to 10 volt. We normally always have 0 to 5, so I was a little surprised to see 0 to 10. It's just an option. It's a checkbox on the form when you order the equipment. Okay. Do you want the 0 to 5 volt, or do you want a 0 to 10 volt? 98, 99% of our units across the entire country are the 0 to 5 volt, and that's still what we were buying.
But you're saying this is set up for zero?
It's not set up. That's what it comes from the factory.
Okay. So I want to make sure that somebody didn't do something that doesn't match the G-Bass.
It's a checkbox on the order form. Okay. They ordered this one as a 0 to 10.
But you would need to make sure that when you order a G-Bass, that you're getting it for what you're setting up here.
Correct.
So, okay.
Yes, correct. It's a different. It's not something you change here. I would say it's a different firmware, something in the board.
Sure.
It's a 0 to 5 or a 0 to 10.
Okay, cool.
So what that 0 to 10 volt, there's a 0 to 10 volt output on the controller, and we tie it into a TB17. There are 4 G-Bass inputs here. There are 4 of them. So 1 and 2, 3 and 4, 5 and 6, 7 and 8. You can have up to 4 inputs.
Okay.
So our supply air set whatever, and you have to assign input 1 what you want it to be, and I'll kind of walk through that a little bit. So let me see what we use this one. So I'm talking to this one.
I'm just gonna move your bag so you don't run into it.
So I went to setup, and I went to the G-Bass section.
Okay.
So G-Bass analog input 1. Remember, there's 4.
Mm-hmm.
There's 4 inputs. So that number 1 is assigned as supply air cooling set point.
Okay.
So that's out. So TB17, 1 and 2. That's our 0 to 10 coming in. That's our 0 to 10. And we configured that input as supply air cooling set point.
Okay.
So that the 40 to 90 degree range is your 0 to 10. Okay? Is your 0 to 10. So we use a small version of that 40 to 90 range. We're going to use 50 degrees to 75 degrees.
Gotcha.
Is our range. And if I go to...
So you're going to send a set point signal over to the G-Bass, and then it's going to start talking to the RTM and the MCM, right?
So in its simplest terms, we got down to 72 degrees. We locked out the cooling, right, through that demand limit contacts.
Mm-hmm.
Our supply air set point, it's showing 75. Let me go, let's see where to find. Right now we're giving it 6.72 volts.
Okay.
The unit sees 6.72 volts
Controlling sensor.
Controlling. The unit sees 6.72 volts.
Mhm.
Remember, we're 0 to 10, 40 to 90. But we're going to give it 75.
Right.
So we're giving it 6.72 volts. The unit sees that as 75 degree air.
Okay.
All right. So we're at 72 degrees temperature downstairs. Our set point is saying 75. We've locked the cooling out through the demand limit contacts. Now that temperature starts to increase downstairs, 71, 72.1, 72.2. It's going up. You're going to start to see this tick down because the software is seeing that the temperature is getting warmer. So it's going to go this down, this down, this down, this down, this down, this. Start going towards 50 degrees.
Gotcha.
Once your temperature gets above, at or above set point, we're going to release and say, you're allowed to run cooling now, unit. You're allowed to run 100% of your cooling. The unit says, hey, I can run cooling. Hey, I'm being told to give me 50 degree air.
Okay.
So now the unit will start the cooling and start stage compressors up, that K9, 11, whatever those relay numbers are.
Right.
And bring on the cooling because the unit has its own discharge air sensor.
Sure.
And it wants to make 50 degrees.
Right.
Because that's what we're calling for. So we're at 74. We bring on one stage of cooling, two stage, maybe it takes all four stages to get to 50 degrees.
Right.
Now the temperature downstairs all of a sudden is 73.9, 73.8, 73.7. You're going to see this go from 50 to 51, 52, 53. As the temperature's going down, this is going up, this is going up, this is going up, going up, going up. It may get to 60, 62, 63 if this keeps falling. If this levels out, well, then this will hold.
Okay.
If this keeps falling, this goes up. If this starts to increase, then this would come down. So it's just kind of sitting like this.
Right.
If it gets to the point where we got too cool and this rose up, it'll obviously the unit's going to stage off compressors, right? And we got to a point down here where we just got too cold, then we'll lock in them, then we'll disable the cooling again for those demand limit contacts.
Gotcha.
And then it'll warm up and the system will start itself all over again.
Okay.
That where the software is looking at space temp and providing a set point to the unit. Now, obviously the VFD is a big part of that as well, right?
Sure.
So that all has to be in balance. And it used to be easier to be in balance. When this store was opened, we had, this isn't that old store, we probably had 105 watt spotlights, incandescent, a lot of heat load.
Yeah, you said a lot's changed on the heat load.
So these units, and it doesn't matter if it's central plant. So I've been with Macy 30 years.
Okay.
In April will be 30. And I've seen us go from halogen and quartz and 150 watt spots down to 120, down to 105, all now LED, and now you got the case lines, you got BTUs of heat in the building, but you've taken so many out. But we haven't downsized this equipment.
Right.
So the way it was a central plant or these rooftops, they would run, you'd run a central plant all day, even in a northern climate. You'd run a central plant all day. Your VFDs might run at 40, 50%. You were giving yourself a 48 degree chill water set point. And it just balanced out because you had that heat load in the building.
Right. These
units, you ran mechanical cooling all day at a pretty good low discharge temp below dew point. You had constant dehumidification going on. Things were just a little easier. Now, when you bring on this unit and you give me 50 degree air, and I've got that VFD humping at whatever I want to call max, maybe 90%. 80% on the VFD curve is kind of where we try to limit, because at that 80% on the VFD, you're delivering 80% of the CFM design, but it only costs you 50% of the motor horsepower. So that's where we try to, you can get 20% more air to go from 80 to 100, right?
But you're going to start losing efficiency.
It's going to cost you double the amount of money. So we try to live at 80. Some will go 90. Maybe this unit serves center core, cosmetics, and you just can't ever keep up. So we let them run at 100. So you'll see some stores that run at 100. This unit might be at 100. That unit might be capped at 90. That unit is in second floor furniture. Nobody's ever up there. There's no heat load. Maybe 80 is fine on that unit. Again, that's all in software because we control the drive directly.
Right.
So you can balance your airflow a little bit like that, or in deliverables, cooling BTUs. This, in relationship to the drive, is really important because, again, if you got that drive, you're in the gas and you're giving me max CFM, whether it's 80, 90, 100%, and I got that at 50 degrees, and I release that cooling, that dry bulb set point downstairs, I'm gonna make that with this LED world we're in. I typically make that fast, and that fast is variable by store, but I'm gonna make that quick. So now I've got 2, 3, 4 stages running. I've got dehumidification, I've got condensate. Now all of a sudden I've 1-2 degrees below set point and I got to shut this unit off. I didn't run long enough to dehumidify, and now I've got a shitload of condensate sitting in there that's back in the airstream, and you watch that humidity go up.
Go back up.
And then you start it off, you bring it down, and then you turn it off and it goes right back up. The dang humidity looks like this instead of where you have mechanical running at some level all day when you had a lot of heating.
Like
BTUs,
a chiller. Yeah.
Like a chiller. Where it's, so some of the strategy changes we've made to rooftops like this is we'll do some offsets in the program, meaning, okay, we're getting up towards 74 degrees. We're getting close to set point. This is coming down to 50. Let's release this at 50 degrees, release mechanical cooling to run, let's say at 73.7 degrees. A couple tenths before 74. Let the cooling run. So now I'm going to get 50 degrees coming off this unit with maybe only one compressor because my VFD is running at 30 or 40%.
Because it's too slow.
Real slow.
Yep.
And now I've got, I'm not using a lot of power on the unit because I'm only running maybe one stage of cooling. The fan's at minimum. I've got good supply temperature. I got good dehumidification off that coil. I'm below dew point. And I'm not throwing all the cooling BTUs into that space. Now, if one stage of cooling doesn't match and the temperature keeps going up, okay, well then that fan will start ramping up slowly. But I release cooling here, get a good cold discharge, cold deck, and then I say, okay, now I let my VFD go up beyond that.
Okay.
So to try not to, just get in the gas and flood the store and then turn it off.
Right.
Flood the store and turn it off.
Right.
It just, a lot of our stores have that older strategy, and you don't.
It is what it is.